Hello, it's Mr. Cerisa, and this time we're going to talk about speed of sound type problems. So this happens a lot when there's a really loud sound and one person's standing close and they hear it pretty quickly, and then the other person's further away and they hear it a little bit later. And so we use the speed of sound in order to solve the problem. So the first thing is make sure you know what the speed of sound is for these problems. Although I'll probably give it to you on the test, or I will give it to you on the test. So speed of sound is 1100 feet per second. And so we'll use that to solve some of the problems. So that's the first thing to make sure that you know going into these problems, is that this is going to be necessary. Another thing that you need to make sure you know is that with hyperbolas, remember there's a constant difference between the foci and point. So just a little tiny sketch that we're going to do. So we have a point here, and so we have our, actually let's put another point on the graph here, and then I'll put in the two foci, so we have a foci there and a focus there and there. So the difference between this and that point is going to be constant. So if we put a point right on the transverse axis, then what we're really saying is the distance from this focus to the point. So that will end up being, well, this whole thing is C. So from here to here is C. And then this little part is A. So really that ends up being C plus A. And then minus this little section in here, and that's C minus A. So minus C minus A. That's going to equal some constant difference. And so our constant difference, let's work this out algebraically. So C plus A, distribute that -1, and you have a minus C plus an A. And then so C minus C cancels, A plus A gives you 2A. You can see that constant difference is always going to be 2 times A. And that gets us pretty far when we're solving these problems. So let's work out the problem number 74. And we're going to do that on page 672. And the problem reads, suppose that two people standing 1 mile apart both see a flash of lightning. After a period of time, the first person standing at point A hears the thunder. 2 seconds later, the second person standing at point B hears the thunder. If the person at point B is due west of the person at point A, and if the lightning strike is known to occur due north of the person standing at point A, where did the lightning strike? Okay, this is probably one of the most complicated problems that we have to deal with. So let's first just sketch that out and see how things are. So we're going to just give ourselves a nice little graph and map out what it looks like. So first we have a person at point A and point B. Those are actually our foci, the people standing there. And then we have another point up here, and I'm going to call that L. That's the lightning striking. And so that lightning is actually on the hyperbola. And so let me do another one over here. Okay, so we already said that B and A are 1 mile apart. Okay, which tells us that the distance from the center to A is going to be half a mile. Alright, so the thing is, we're dealing with the speed of sound, and that's in feet per second. So let's turn that into feet. So I know I already have it written down, but I'm going to write it again. 1100 feet per second. Alright, and then so our distance our distance C to the focus is going to be 1/2 of a mile, which is 5280 divided by 2. So that's 2640. So we have C. And then we also have our A. because if the speed of sound is 1100 feet per second, and the difference between A hearing it and B hearing it is 2 seconds, so if that's x, this would be x plus 2. 2 seconds will equal 2200 feet. That's how far the sound traveled to reach him 2 seconds later, or that's the difference between the two. And so that equals our constant difference of 2a, meaning a equals 1100. Okay, so we have C, we have A, and now we just need to find B. And so we know B squared is going to be A squared, C squared minus A squared. So that will be the 2640 squared minus 1100 squared. And so B squared will be 5759600. Alright. And then just let's find out what B is as well. So B is 2400. Or it's approximately 2400. So I'm going to use that. So here's my B, here's my A, and I'm going to set up my equation. I know that the transverse is the x-axis, so I'm going to put that in first. My A, I just found out was 1100 squared, and my B is going to be the 2400 squared. We want to find out where this lightning is striking, or how far it is from person A. So person A is standing at the 2640 mark, basically, is what's happening. So it's 2640 away from the center, so that's the x coordinate. And I'll work that out. If you want to set it up, you could do it this way, 2640 squared over 1100 squared. And what I'm going to do is add the y squared over 2400 squared to the right side and subtract the 1 over to the left side. So that makes it a little simpler. And then if you want, this is what I like to do. So I took this 2400 squared and multiplied it to both sides. So 2400 squared on both sides. And that will be my y squared. And so if you just take the square root of all that, and take the square root of this, and they cancel, then put that into your calculator, and you'll end up with y equaling 5236. And that's in feet. So you can say A is standing 5236 feet from the lightning strike. And that's all that I have for this problem. It can get pretty tricky, so you may want to check this out a couple of times. But thank you very much. I hope that it helped.